So this is where we got to last week. I think just a quick, I'm just going to delete this. Just a quick refresher on what we'd done. We were dealing with position tolerancing, and I'd set up two different ways of position tolerancing. This one here, which I now can't remember, is symmetric, that's right. And this other one here, which is the fit with tolerance here on the left-hand side. Okay, so, and remember I explained to you that you can create a zone of tolerance, which is a neat way of picturing what your two dimensions are going to do if you put plus or minus, and remember I used 1, which is very large, but if you put a plus or minus tolerance on that thing, and this was the alternative way, and this has got benefits in other situations, but we're not going to deal with this in too much detail. I just need you to understand that it can be applied and will be used, and then to go through a little bit more detail, and then I will deal very briefly with filling out the title block to my satisfaction, so that you have all of that correct for your moderation, which is very soon. I think it's a month and a bit. Okay, all right, so the first thing I want to do, I have created, let me just show you, I have created a version of this this block with two pins today, and so we're going to figure out what happens when we position these two with a tolerance, and obviously how that affects how they fit inside those holes over there. Okay, so I'm going to go back to my drawing, and the first thing I want to do here is this drawing is way too small, so I'm going to just, before I do anything, let me update it. I'm going to right click on sheet, this, there we go. Okay, so go to the sheet what you'd call it, sheet command, and right click and go to properties, and in properties you'll have all of your standard sheet sizes, which you can show as only standard format if you want, but obviously, because I want to grab hold of one of my sheets, I want A2UJ, and I'm going to say apply changes, and you'll see it instantly updates to all of the settings I have for that sheet. So once you've got things set up, there's huge benefits. Oops, we've left I'm going to delete that for now. Go across to my view palette, and this is a trick I'm going to show you in the sheet metal section when we do that from next week. So I'm going to bring one of these in, I'm going to say the back. Alright, so you'll see that that drawing is the same as this drawing, but in fact in my actual model I've created configurations. So when I'm in this drawing, I should be able to go to the top here, and you can see it says reference configuration, and here are my 3 configurations: default, add 2 prongs, and position tolerance pins. So if I select this one, it'll update the drawing to reflect that configuration. So yeah, that's a neat trick, a neat way to not do a lot more work than you need to, is just to work with configurations and change things as you need them. Okay, so I want to disassociate this view, so I'm going to right click and go to, where is it? Never can figure this out. Alignment. Break alignment. Okay, so now this is not aligned with that top one, and it's put in a center mark for me. Okay, so I'm first going to establish my datums again, just because this would be on a separate drawing. Of course, I'm being lazy, or I'm not being lazy, but I want to be able to go back to these drawings. So I'm putting this on the same drawing. So we're assuming this would be a new drawing. We put datums in. What I noticed quite a few of you doing in your drawings is you would do something like this. You'd create a new view. Okay, and then you'd put actually this isn't going to work. In fact, let's just, this is what some of you are doing. You weren't doing that, okay? You were going to this view, and for instance putting this, sorry, now wait a minute. Now I remember. Right, you're putting it there, that's right. Okay. Oops, doesn't want to do it. I think you get the picture. So please put your datums, I suppose I could say this simpler. Put your datums in the view in which you see them. So if you've got a datum that somehow relates to this view and it's in the second view, in the right hand view, and you put the datum there, that's not good practice. What you want to do is you want to put the datum in the view in which you find it. So that's one datum, that's one datum. Bit sticky today. Keep those in this view. And then the same goes for your dimension. So if you dimension a position dimension for this hole, you must please put the geometry in this view as well. So don't put the geometry in another view. So I'm going to do that incorrectly now. Right, so that's not good practice from my point of view, just because that diameter symbol best goes with this view here. It doesn't best go with that view because I can see that this is a circle and that corroborates that it's a circle. And in any case, this is the best place to put my my position dimensions. Just does not seem to want to work today. 1, 2. Okay, so there's one. So if that's your one position and this is your other one, there we go. Okay, so yes, okay, if this is not positioned correctly, you can sometimes, it depends on how the dimension is selected, you can select one of these points and pull it out, for instance like that. Okay, so that's not what I want, but goes back. Alright, so that's just a basic principle. If you have your two position dimensions, please put the size and geometry dimension in the same place. One of the other things to check is it's very easy to do this if your setup isn't correct. It's very easy if your leaders, for instance, go with radius, to leave it like that. Just watch that. If it's a circle, it must please say circle. So two ways to fix that up. The easiest way is to go to leaders and just make sure you're selecting diameter. Here's radius and there's diameter next to it, and make sure it's selecting one arrow. Okay. Right, so this here, let's just explore a little bit what happens when we play with this dimension. So I'm going to go to my dimension types and I'm going to select the symmetric one, and I'm going to give it a value of plus or minus say 0.125, because that's half of 0.25. In fact, let's make it a standard deviation on position is usually about 0.35. So half of 0.35 is, it's about, let's say it's about 0.18. That's about right. Yeah, that's perfect. Okay, so that's plus or minus 0.18. Last week I suggested to you that this wasn't the best way to do a position tolerance because it gave you a little square like this. Now I don't have enough time to explain exactly how this works, but I can give you quite a few videos online to go and check it out. A better idea is if we were to set this zone up as a position tolerance, called a position tolerance, and I should be able to do it from geometric tolerance. Here's this little block here, and I am not sure where to find it yet, so I haven't played with this yet, but it is in here. Let me see. So these are just different types of tolerances that you get. So that's straightness, flatness, circularity, cylindricity. You can go through them. These are just variations. So for instance, a flat surface isn't straight ever in the real world. There's flatness. Circularity, nothing is ever completely circular. Cylindricity, the same thing. So you can set up tolerances for all of these things. And right now I'm trying to find just the tolerance one. It doesn't seem to be in here. It is in here, but I haven't played with this yet. Okay, never mind. But the idea behind the tolerance dimension, which I'll try and fill in an updated edit of this, is that instead of creating a zone, which would be 0.18, just pull this out. So let's just draw that zone in. So from the center, which would be from, you're going to give me a center, dude. Okay, so this dimension should be scaling, but it's not. Right, so instead of doing that, a much better way of tolerancing this would be to create a zone which looks like this. Okay, so the zone, if you start getting used to position tolerancing as it's used in what's called GD&T, that's geometric datum and tolerancing, they will use a circular position, which gives you a much greater area of tolerance. So the area of that circle is much bigger than the area of this square, but it has, if I can get this right, it has the same maximum position no matter what you do. So if I draw a radius here and I extend that radius, or if I drag it round, not going to do it. Let's draw another one in. To any other point, these two are exactly the same. So remember last week I spoke about, let's go back, I spoke about putting these four circles on the four corners, and that gave you a circle which is like a zone of tolerance. Well, what we're really doing here is the same thing. So instead of using a plus or a minus 0.18, we just use a zone tolerance, which is a simple circle. So I'm letting you know that this is how you can do it. I didn't have enough chance to go and research properly and figure out how Solidworks does it, but I'll update that. So that's all I want you to know for now as far as zone tolerancing goes. I'm not sorry, position tolerancing. that instead of putting a plus or minus 0.18, we can, or maybe we can do it in here. Let's just have a look. Symmetric min-max. No, it doesn't yet show me. There is a way of doing it, but I haven't yet figured it out. So instead of putting a plus or minus 0.18, you'd have a plus or minus, and it would have something like a circular thing, but it would be this thing here. You would put a block in with a few symbols and 0.18, for instance, and then you would add other tolerances to here. So for instance, your maximum projected tolerance, translation. Okay, so it seems like as soon as you put the symbol in, that you can start determining what that does. So that little block would go there, and then you would take away, you would make this basic. So that would start telling you how your tolerance is going to work. So don't worry about it too much for now, just so that you're aware that this is what you can do, and this would be very sophisticated if you did it in industrial design. But if you ever need to deal with engineers and they ask you about tolerancing, you have some idea of what you're talking about. Okay, so I'm going to delete that and go back to symmetric. And then there's not a lot here to really discuss. It's just that plus or minus 0.18, if it's done like this, if that's my center line, just put a note in quickly. Okay, if that's 60 plus or minus 0.18, that would be divided. So I could go 30, I could go from that position to this position, really doesn't want to do it. Okay, my apologies. I'll tell you what I'm going to do quickly. Sketch. Let's do something like this. That's why. Okay. Okay, so that I'm going to just fill in. That would be plus or minus 0.18, and then you have the same on the other side, 30 plus or minus 0.18. But no matter what you did, the 60 could not exceed 0.18 overall. So if that were 30 plus 0.18, then this dimension here would have to be 30 straight, if that makes sense. And if that were 30 minus 0.18, then that could become 30 plus 0.18. My apologies for the poor presentation today. I was trying to get your marks done, so that's what I focused on. Okay, so this is a way of limiting the amount of error that could happen across a center line. I'm going to delete this and just put my center line in just to be correct. So center line between that point and that point. There we go. That's what we need. It's a proper center line. Got it. Does that add up for you guys? I hope it does. Because if the center line wasn't in place, then this 60 could shift a whole 0.36. So this circle here, let's just duplicate that one quickly. Wow, 27, right, 27 divided by 2, 13.5. So that there could shift a full, not going to work. Alright, so this could shift a full 0.36 if I didn't have the center line in place. So these two could shift a whole 0.36 to one side legitimately if the center line wasn't in place. I think that makes sense. I hope so. Okay, so we're running out of time, right? So let's quickly go to the title block, because that's probably what we need to deal with. So the first thing to do is to edit your sheet format. Let's go from the top. So issue 1 is what you're always going to do. Then please do fill out the date. So whatever date that you did issue 1, so that whoever's looking at this can see what the date is that the issue was made. And then you can just leave for discussion in the first one. In the second one, you would typically put in what some of the revisions were. So let's say you'd done another one over here. Okay, I don't have a text block in there, so I'll actually put one in and update this. So that you just have to click on the text box. So let's say, for instance, now you put in a dimension, and you would normally ring it. So dimension A was 3.5. For instance, this you don't have to do this for me, but this is typically what you would do. You would have dimension A was 3.5, and then you would actually go back to your drawing and put an A in just to mark where it was. And then please just put your initials in here, so P.D or PDP, caps lock, make sure it's in caps.
Phil?
Yeah.
Sorry. What does your screen look like? Because I think mine's frozen, but it just disconnected and reconnected, and it still looks the same.
At the moment, it's just got the lower right-hand corner of the title block with a for discussion, and dimension A was 3.5.
Oh, okay, no, then mine's got an issue. I'm going to try and disconnect again, sorry.
Okay, all right. Okay, so then client, you should put my name in here, please. Or UJ, I don't mind, UJ. Just put something in there to tell whoever's doing it who you're working for. You know, so if you were working for Mercedes-Benz, you put in Mercedes-Benz. And then the drawing number, you should have a drawing number scheme of some sort. So I would suggest something like maybe your initials and a forward slash or a dash or an underscore, doesn't really matter. And then maybe go by project. So your project 1 would be 1, and then another dash, and then give it like 3 numbers so that you can change that. So drawing number 001 would be your first drawing, and then in the same project you could change that to 2. What I like to do is I like to be a bit more descriptive. So in somewhere in here I like to put 1 maybe, and say key for key fob or some sort of code, KF. Up to you, but just put a number in that looks like it's got a system to it, so that you could go to whatever you're looking at and find PDP would be whoever did it, although that's not normally what you would do. You would have the project number, the project name, so you could call that KF, for instance, and then this could be 1K, and then that would be the sequence. So all of your drawing numbers would start with some sort of key to the project, another key to the part of the project you're dealing with, and then the last one is the actual number. Then the project quite a few got this not right. So key fob in this case is the project, and the title is whatever is in the drawing. So either it's the upper casing, so that could be one thing if that's what it was, or lower casing, and that's it. That's all you'd put, upper casing. So I can see what the project is and I can see what the name of the drawing is. If it's the key fob, if it's the assembly, then you would normally put G.A, that's general assembly, and then you can explain it as exploded. Alright, if you've used an exploded view. Otherwise GA, if it doesn't have an exploded view, you could just put GA. Then please do put your name in here, so your full name. And what I would suggest is go and populate some of these bits of your drawing and update your own drawing templates. So that, for instance, like in date, you could put XX-0X-2021, so that every time you come in here, you don't have to fill out the 2021. You can just go to so you only fill this out once, because that's the first time you draw it, and then after that it goes to your issues. And then obviously you should put your name in here, and then please fill out things like materials, color. So if it's material, so this would be ABS, for instance. Color would be white, or you could, if it was something specified, you could say per BOM, B.O.M. Finish, you could say the same, per BOM. And then here, I'm not going to deal with this right now, but this is where you could put in, actually, in fact, you can do this. So this you could put in a plus or a minus. See if we can find that. It should be in here, plus or minus 0.25, and then your angle, that could be the same. Let's say that's 0.25 of a degree. Just put the degree symbol in as well, so that at least you're getting used to filling out some more details than just what's in your drawing. Then obviously it would be a good idea to put your logo in here. You can just delete this, and you should be able to go to the top here and insert picture. Go and find your logo wherever it might be. Whatever, I don't know if I'm going to have any images in here at the moment, but you can go and find an image file and just drop it in there. So pretty sure you know how to do that. So drop that in there, and then once that's all done, that's finished. Any questions about that? So it's not really difficult. It's just a matter of filling it in, and most of this is done for you. You just have to fill in some of the details. Yeah.
I also can't see what you just filled in. I can just see this block that's like, I think it's frozen on this page for me. Can you just like maybe take a screenshot or something of the completed title block and put it on the group?
I'll do a screenshot and I'll post it, but it's also going to be recorded, so I'll post that as soon as this is done. Okay.
Okay, cool, thanks.
So we are almost up as far as time goes. It looks like, can't see how much time we've got left, but that's all I'm going to deal with for today. That's because I was not that prepared, because I was, as I said, focusing on your marks. But next week we're going to have a double session, and we must deal with sheet metal. So as many of you as can be here, please be here. And then I will also post for you your next project, which will be oh, by the way, let me just exit this. So we say once you've finished, edit sheet, and your drawing comes back. So I'm going to be asking you to do a I'm going to ask you to go and grab a a model off of GrabCAD. I'll give you the address, the web address. Go and register if you want on the site. Grab a God, my brain's not working. Grab an aluminium extrusion, and I'll show you which type to grab, and then I want you to remodel it, but change it, and then create 2 other extrusions that you're going to add to it with some sort of range of movement in them. And then I want you to give me position and size dimensions, and make sure everything's properly dimensioned. So that's going to be worth quite a bit of marks, by the way. So a fairly simple project, but worth quite a bit. And then the last project we'll do is a sheet metal project, also hopefully not that difficult. You guys have actually covered, for this last project, the most difficult stuff you need to cover. From here on in,